है सेमाफोर। तो लास्ट लेक्चर के अंदर हमने देखा कि सिंक्रोनाइजेशन जो है, इंटर प्रोसेस जब कम्युनिकेशन होता है या मल्टी प्रोसेसिंग के अंदर रिसोर्स शेयरिंग में वो बहुत इंपॉर्टेंट चीज है। हमने ऐसे देखा कि जो सीक्वेंस है वो प्रॉपर होना चाहिए। सपोज कोई रिसोर्स जो है जब यूज होना चाहिए तब ही यूज होना चाहिए जिस प्रोसेस के द्वारा, और उसके बाद दूसरा प्रोसेस उसको यूज करना चाहिए। अगर ऐसा प्रोग्राम का डिमांड है तो उस मैनर में वो यूज होना चाहिए। तो उसके लिए सेमाफोर जो है वो भी यूज किया जा सकता है। तो सेमाफोर एक वेरिएबल है जिसकी वैल्यू के ऊपर हम रिसोर्सेज को शेयर करना कंट्रोल कर सकते हैं। तो हम फॉर्मल डेफिनेशन देखेंगे सेमाफोर की। So a semaphore is a variable that provides an abstraction of controlling the access of shared resources by multiple processes in the parallel programming environment. So ये यहाँ पे ये बोलना चाहता है कि सेमाफोर जो है वो एक प्रकार का वेरिएबल है जो हमें हेल्पफुल होता है फॉर कंट्रोलिंग द एक्सेस ऑफ शेयर्ड रिसोर्सेज by multiple processes in the parallel programming environment. तो स्टूडेंट्स जो सेमाफोर्स होते हैं वो दो प्रकार के होते हैं। वन इज बाइनरी सेमाफोर। So meaning of binary semaphore means what? It has only two values, either 1 or 0. So binary semaphores can take only two values that I said, value 0 or 1. So binary semaphores have two methods associated with it, up and down. तो जब हम बाइनरी सेमाफोर का यूज करते हैं तो हमारे पास दो फंक्शंस होते हैं। थ्रू दैट टू फंक्शंस we can control the lock and unlock on the resources. So that function for locking it is up and for unlocking it is down. So they are used to acquire the locks. So these binary semaphores are used for the acquiring the locks and releasing the locks, right? Counting semaphore, as I said, binary semaphore के अंदर जो possible values होते हैं वो दो ही होते हैं, 0 and 1. For locking and unlocking, but in counting semaphore can have a possible values more than 1. तो उसके अंदर एक से ज्यादा values होते हैं। तो as per demands or as per our programming, we can use these semaphores, right? Now students, we will see the classical problem of read and write using the semaphore, right? So whenever we want to read or write into the database, so it should be in a synchronized way. So suppose we want to read something from database. Suppose a process is wanting to read from the database. So for that, rule is that more than one processes can simultaneously read from the database, but they cannot write. So from this figure, students, you can see process P1, P2 and P3, they all are reading. So it is allowed. So when the P1 is reading, it will allow, or it is allowed that the P2 should read and P3 also should read. But P2 and P3 are not allowed to write. Right? So this is reading. Right? So in that, what we do is we increase the reader count. Right? So we will see the algorithm for reading and writing. In that, we will see how the variables are managed. Now, when we are writing, suppose a process is say writing something. So at that situation, no other process is allowed to read or write. So you can see from here this figure, when the P1 is reading or if P1 is writing, P2 and P3 are not allowed to read or write, right? So this is the you can say a reader-writer problem. in the database, right? So in the reader-writer problem, many competing processes are wishing to perform reading and writing operation in the database. It is acceptable to have a multiple processes reading the database at the same time. But if one process is updating, that means writing database, no other process may have access to database, not even for reading. So how to implement it through the semaphore, we will see that. So in this, we are using three variables. One is mutex, is a type of semaphore. That variable is semaphore variable, and another is db, that is for controlling the writing, right? Writing to the database, and another variable which is integer variable, which is showing us or which is telling us how many readers are reading just now, right? So here from this algorithm, first we will see the reading. Suppose a process is entered as a reading. So what it should do? As I said you from this figure, when a process P1 is allowing, allowed to read, so it should allow other processes to read, but not to write, right? So here, while true, down mutex. So what this will do, down mutex means what? It will unlock to read, right? So it will unlock to read to the current process. So reader count will be incremented by 1 because it is the increasing the number of readers, right? So now suppose that reader is the first reader. So as I said, when we are reading or when any process is reading, it will not allow any process to write to the database, right? So what it will do, it will down db, so prevent writer process to access, and up mutex, allow other processes to access the read count. So it is locking the writing, but it is allowing other processes to read. Now it is reading the database, right? Now it is downing the mutex, right? So the gain access to read, right? So again it will get the access to increment or decrement the reader count. So here now this has performed its reading, right? So when it entered in the reading, it has to increment the reader count. Why? Because one reader is reading something. Once it has completed its reading, so it should decrement whatever it has incremented because its work is over. Now reader count is equal to reader count, right? Now if the reader count is equal to 0, that means what? This was the last reader to the read and it has completed its reading. So what we should do? We should allow other processes to write something, right? Suppose there are 3 processes which wants to read and they are reading. So one has completed, second has completed, and third is completed. Meanwhile, other process wants to write something. So that process will be waiting that all the processes completes the reading, and after that I should allow to write. So this situation is controlled or is achieved by this. So if the reader count is equal to 0, so it will up db. That means leave the control of db, allow writer process, right? Now as we know that once the writing is allowed, allows the processes to access read count. Now at that time it can allow to read also, right? So allow other processes to access the read count, use read data, use the read data from database non-critical. So this way the reading is achieved. So whatever our requirement was, that at the time of reading, all the other processes should read, no other process should be allowed to write. But once the reading is done and following that some other process wants to write, it should be allowed, right? So that is achieved through this. So when we are entering in the reading, we should be ensured that if it is first time, then we should stop other processes to write. And suppose all the processes are completed of work of reading, so at that time it should allow any other process to write in system, right? Now this is known as a reader function. Now what is the writer function? As we know, at the time of writing, it should only write, no other process should be allowed to read, right? So first of all, this is while true, create data. So it will create a data. This is a function which will create the environment to write something to the database. Now down DB, what is the meaning of it? It is giving the access to write into the database. And write DB, this is a function which is writing into the database. Up DB, now release the exclusive access to the DB. So when we are writing, at that time, what we are doing, we are not allowing anybody to write into it. So after writing, it should allow others to write also. So UpDB will release the exclusive access to database. So students, in this way, we can do the reading and writing, and we can achieve that functionality in operating system through Semaphore. I hope you have understood the concept properly. So thank you very much.